The atomic theory of matter is the theory that all matter in the universe is made up of tiny particles. Atoms, such as hydrogen and oxygen, can bond together to form what are called molecules. So if you see an atom on its own, it would be represented as just a single letter, or perhaps two if its name included two. This is the chemical symbol for sodium, which is an atom. And then C is carbon. And this molecule is, of course, our familiar water. Either atoms or molecules could be referred to as particles. Particles of three major states of matter, solid, liquid, and gas, are shown below. These particles are actually believed to be in constant motion, even in a liquid and a solid. Since the particles have both mass and speed, they individually must have kinetic energy. And the kinetic energy of an object's particles, on average, is proportional to the temperature of that object in kelvins. Spacing between particles, as you can see, is quite a bit larger in gases compared to liquids and solids. And collisions between the particles result in changing velocities and speeds for these particles. So just imagine two of these on a collision course. That's before the collision. Then they exert forces on each other. And then they shoot off in some other directions. So, when the particles collide, we see that transfers of kinetic energy can occur. Now, the three states of matter that are represented here are solid, liquid, and gas. Solid has both a definite volume and a definite shape. And the volume of solid can change subtly under certain conditions, but solids are generally thought of as incompressible. A liquid is a fluid that has a definite volume, but liquids, they don't have a definite shape, so they will take the shape of the container that they're in. Volume of a liquid could also change subtly under certain conditions, but liquids are thought of as incompressible generally as well. A gas, on the other hand, is a fluid with no definite volume and no definite shape. Because the gas particles are so far apart on average, they're considered not to interact except during microscopic collisions. But gases are compressible. The volume and density of the gas can change as its container changes its volume.